Limit is x goes to pi over 4 of cosine 2x divided by cosine x minus sine x. The first thing we're going to do is try plugging a pi over 4 in for each x. In the numerator, that'll give us cosine of 2 pi over 4. In the denominator, that'll give us cosine of pi over 4 minus the sine of pi over 4. 2 pi over 4 can be reduced, canceling out the 2 and the 4 to leave a 2 in the denominator. So we have the cosine of pi over 2 divided by the cosine of pi over 4, which is a root 2 over 2, minus the sine of pi over 4, which is also a root 2 over 2. Cosine of pi over 2 is a 0. Root 2 over 2 minus root 2 over 2 is also a 0. We have the 0 over 0 indeterminate form. In the numerator, this is resulting from the cosine of 2x, which has an identity. It can be replaced with cosine squared x minus sine squared x. And that's a difference of squares and can be factored as a difference of squares. So that's going to be our next step, is to replace the numerator with cosine squared of x minus sine squared of x. We still have the 0 over 0 indeterminate form, and we'll continue to have that until we factor cancel, but it's a factorable expression. In the numerator is a difference of squares. It will factor into cosine x plus sine x times a cosine x minus sine x. And in the denominator we will have a cosine x minus sine x. And we can see the factor that's making 0 as x goes to pi over 4 is the cosine x minus sine x in the numerator and denominator. Now that we've canceled those out, we should no longer have 0 over 0. And therefore we should be able to plug a pi over 4 in for the remaining x's. So now we will do that, and we will have the cosine of pi over 4 plus the sine of pi over 4, which gives us root 2 over 2 plus root 2 over 2. They are already over a common denominator. We can add them together to be 2 root 2 over 2, and the 2's can cancel out to give us root 2.